Now let's see how the action potential is generated in a single cardiac myocyte. We call it a non-nodal action potential to differentiate it from the nodal action potential that we saw earlier. Here is the graph, time on the x-axis, time in seconds, and membrane voltage in millivolts on the y-axis. Let's make a few markings. Minus 90 millivolts, plus 20 millivolts, and 0 millivolts. At minus 90 millivolts, sodium channels open and sodium rushes in, causing depolarization and opening of many more sodium channels in a positive feedback loop, and the voltage reaches plus 20 very quickly. This voltage is maintained sort of by the opening of calcium channels and the slow inflow of calcium. The repolarization is brought about by the opening of potassium channels and the fast outflow of potassium. So we have it here, the depolarization, fast sodium inflow, the maintenance of the depolarization by slow calcium inflow, and the repolarization by fast potassium outflow. The maintenance of the depolarization is called the plateau, and as you can see, it is brought about by slow calcium inflow. This is what makes the absolute refractory period extremely long, as a result of which the cardiac muscle does not go into tetanus. Putting a pet down to sleep can be a very traumatic experience. This is accomplished by giving the animal a potassium chloride injection, which results in cardiac arrest and death. Let's see how a potassium chloride injection can lead to cardiac arrest based on what you know about a non-nodal action potential. So when a potassium chloride injection is given, the levels of potassium in blood increases because that's where it ends up. The potassium ends up in the blood. So the potassium levels in the extracellular fluid, ECF, is greater than potassium in the intracellular fluid, or ICF. This is the opposite of what it is normally, because we all know that there is much more potassium inside the cells than outside. Therefore, as a result of the potassium chloride injection, the potassium gradient is completely disrupted. So when the action potential happens and potassium channels open, there is no potassium outflow, or there is very little potassium outflow. If there is no potassium outflow, then there is no repolarization of the cardiac myocyte. If repolarization does not occur, it will not be followed by relaxation of the cardiac myocyte. So relaxation of the muscle also does not happen, and the heart goes into cardiac arrest, which results in death.